Hey guys, Chris here. I'm going to be in Portland this coming Friday, which is September 11th, and we're going to be having a meetup for electronics people from 4 to 6 p.m. at the Lucky Lab Brew Pub on Hawthorne. So I'm really hoping people that live in Portland come out. I'm going to be there for XOXO conference, but I also know Maker Faire Portland is that weekend, and would love to see you there, would love to meet you, would love to see what you're working on. Please bring your projects with you. So if you can make it, if you're a Portlander or if you're in town this weekend, once again, it's Lucky Lab Brew Pub from 4 to 6 on Friday. Hope to see you there. Now, on with the show. This is the Amp Hour Podcast, recorded September 8th, 2015. Episode 266. An interview with Ronald of Hash Define Electronics. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Ronald, instructor at Contextual Electronics and Hash Define Electronics.
Welcome, Ron. And
hello, Chris.
People might be wondering, first off, Dave is on vacation. And second off, I had Ron here on as a... yes, he is an instructor of Contextual Electronics. He's doing some cool stuff with embedded, but actually I wanted to talk about his background. And he's done some really cool stuff in industry. And so we're going to talk about his background in embedded and some of the stuff he's worked on. So welcome. Why don't you tell us a little bit about yourself?
All right. Well, thanks for having me, by the way. I know it's kind of like a last-minute thing.
Yes, my scheduling abilities are notoriously last minute, but flexibility is always rewarded.
I've kept tracked. Well, I live in the UK. I'm a contractor in electronics. Come from the field industry. That's about it, really. So I do a lot of embedded electronics, and ended up listening to the Amp Hour. Big fan.
Oh, well, thanks, man. So the UK, we like you and I were talking about before the show. We don't have too many guests from the UK, and I think I've mentioned this on the show before. But one of the reasons actually is, just Europe in general, that the scheduling with time zones is actually really difficult. And it's not a great excuse on our part, but, with Sydney and then US and then UK, it's all split apart by, weird hours.
Well, considering the way we set the time zone, we should have the advantage, really.
You'd think so, but then, sleeping and families and everything else, that's the the stinker of it all.
No, so... It's kind of nice to be invited to the show. Really, it'd be nice to talk more about the UK and engineering and this side of things. Really, so
yeah. So let's talk about that a little bit. I mean, so you went to school there, but we don't have many people there, and it's obvious that there is electronics industry stuff like that. So what has been your experience in the UK throughout your career?
The electronics are amazing.
Okay.
Yeah, I mean, to be honest, though, when it comes to engineering in the UK, there's plenty of stuff you can do, a wide range of stuff. I mean, my background comes from fuel electronics, so fuel delivery trucks and all that sort of stuff. I mean, I can't really talk much about consumer electronics. I've not really gone into that sort of things, but it's quite an interesting place, really. Sort of to hear Mike doing contract work down in London. My gripe with London, I tell you. If you're trying to do anything, you warned me not to talk about that, did you? I tell you what, though, when it comes to doing contract work in the UK, if you don't live in Cambridge or in London, you're pretty much having to do a lot of commute. Yeah. And I'm so jealous of Mike for his location, really. But
right. Well, no, and that is a good point. I mean, obviously, there's a lot of overhead in the bigger city areas, but that's true anywhere, right? I mean, like I'm in the Bay Area right now, and there's tons of overhead here as well, but people still make that stuff work. I think it's more interesting just about the just kind of the industries that are even there. So you mentioned Cambridge, that's where ARM is, and there's a bunch of other stuff around.
It's our UK Silicon Valley, if that makes sense.
Oh, okay, yeah. And then what are some of the other industries that you've seen around even London and everywhere else?
Well, we tend to be a lot of digital industries really. So web development and stuff like that down in London. A lot of hardware-less companies.
Oh, okay.
So it's kind of interesting though, because you would have thought that the UK being kind of like the hub of where sort of software kind of became a thing, it's kind of become what London is all about, really. So marketing and chipless companies, you got that in Cambridge, and here up in North, which is where I'm based, Leeds, we tend to be a lot more about manufacturing. So it's kind of
Is Leeds like the Cleveland of the UK? Is that what I'm hearing?
well, I wouldn't say, I wouldn't go as far as saying that.
I don't think anyone would say that, yeah, ever.
Yeah, we do have cheaper houses, but no, it's. To be honest, though, I have to say one thing I love showing off about, and that is that I live right next to Farnell, the main hub for Farnell. So if I need anything, I can just literally just walk over and just pick it up. And to be honest, though, I wouldn't be surprised if that's the reason why a lot of the electronic companies here up here in North.
Interesting.
Kind of have like
right. Yeah. So, and people know. I mean, Farnell is part of what is Farnell, Element 14, Newark. That's all kind of the same thing. And like you said, Farnell is that's one of the big ones. So that means there must be a bunch of stuff around there to support that. I mean, that's I guess they kind of serve UK and then a lot of Europe as well in terms of being able to get parts, right?
That's right. I mean, to be honest, I've never had an issue where if I needed something, I couldn't find it on Farnell.
Right.
So I mean, there's loads of little companies here up in Leeds, well, mostly in Leeds, really, where they've basically focused on very niche markets. I mean, I don't know if you've heard of Cocoon. That's one in Leeds.
No. What is that?
It's a home sort of security system, so like like an
automation.
No, I would say more like a smart webcam, but better than that, because they actually have their own sort of microphone built-in system there going on, where they actually try and monitor sub sounds, as they say.
Oh, interesting.
They were on Kickstarter not long ago, to be honest.
Okay.
So right now it seems to be kind of like a Leeds thing to talk about. Like a lot of the smaller companies tend to kind of be using them as we're going to be the next Cocoon kind of thing. It's like,
oh yeah, right.
that's in Leeds. Damn it, they hasn't actually gone. They have not really released any products yet. So they're still, and yeah, they've been used as a comparison. So I'm not. By the way, I'm not trying to make Leeds sound like a small sort of middle of nowhere place. It's actually quite a lively city.
Yeah, right. Makes sense. No, that's good. That's a good point, though. And there's, and I just get, like, kind of just running through it. It's like, I don't really necessarily think the UK for anything specifically, but then if I step back, I think about, I guess Raspberry Pi's out there. That's kind of more on the hobby side. But
that's Cambridge.
Right, that's another Cambridge one. And that's and there's a lot of industrial stuff. My friend told me there's actually an old chip fab in the middle of the countryside out there. I was really surprised by that.
I'm guessing you're saying somewhere like in the Midlands, possibly. I
don't even know. Yeah, I didn't know where it was. It was like
there's a lot of PC manufacturers in the Midlands side of things. Like from Manchester downwards, it's just a silly amount. It's like every other week I'm hearing one's closed down, but another one's opened up. But
interesting. Yeah, no, I guess Manchester used to be really big for manufacturing, right?
Yeah.
Yeah. Okay. Yeah, because like I said, geography has always been my weak point. I don't really know much about. Yeah. So
I can give you a breakdown if you want to of the UK, but that's going to be a very very quick.
No. Actually, that could be interesting. Like a breakdown of like different regions, even not necessarily cities, but like so like Leeds is known for what? Like, is it manufacturing heavy, like you said?
Well, sort of Leeds, Bradford, sort of that northern side of things, they tend to be quite heavy in manufacturing.
Okay.
Where you've got if you sort of follow it down towards the Midlands, that tends to be kind of like the gaming industry for some reason.
Okay.
They tend to kind of focus down there, and then when you go further down that, you get sort of you kind of get a mixture just before London. Again, kind of PC manufacturers, suppliers, so to speak. And then just suddenly you hit London, and then just basically everybody, it's either digital or hardware less kind of companies, and
right.
It's
Well, we've talked about that a little bit before too. Like why do hardware engineering companies always seem to live out in the suburbs, right? And it's because if you need big lab space or something like that, or if you need a manufacturing floor, you're probably not going to want to pay London type real estate prices. Same thing out here, Bay Area. You're not going to put a huge manufacturing facility in downtown San Francisco, but that's just the reality of the situation. So you're going to find more hardware type companies kind of out in the outskirts, that kind of thing. Maybe a little bit less now because you can get smaller shops that can be, in an office or something like that. But still, the manufacturing, it feels like that stays away from the big cities.
Yeah, I mean, sort of with projects that I've worked in the past, though, with regards to embedded stuff, I always find myself that whenever I want to get something manufactured, or if I want to sort of deal with a customer with regards to some sort of truck and that, you always end up having to kind of drive further down south, find yourself like a sort of the niche, smaller fuel delivery companies, and they're the ones who are willing to try out the prototypes. And but then when you sort of move further up north, they all seem to be a bit wiser. They tend to be kind of, well, if you're going to try it out on our trucks, you're going to have to do a lot more than just sort of borrow a truck for a day kind of thing. It's like, whoa, okay.
Okay. So how did you end up in Leeds in the first place? I mean, like, what, we went to school there or what?
Yeah, I came to Leeds University. Well, that's where I studied and got my master's in. To be honest, it sort of because I actually used to live in Essex with my family and that, and I kind of thought, well, I want to kind of venture out in the world and sort of do my own kind of thing. How far can I sort of move away before where I can start making my own decisions? And I figured, well, let's out of all places, might as well just go to Leeds. And
how far is that even? I don't even know.
It's about 200 miles. I didn't really go far, to be honest. Okay. When you compare the distances to America, sort of city to city, it's a stone throw away, really.
Gotcha.
But no, to be honest, I came to Leeds University because when I went to college down south, there was a teacher there, Bruce Kelly. Amazing guy. He used to always tell the story about how he helped design the automated machines to, the Bank of England.
Yep.
The point where they were phasing out hard labor to kind of check each individual note to see if they've been printed correctly. They were sort of going through a phase. He was the guy who designed, him and a few others designed the machine that automated the whole process. So it'd be done by machines rather than by people.
Oh wow!
And
so like machine vision type stuff or what?
Exactly. So that and sort of also the automation side of things. So the stuff that kind of throw away the notes when they're corrupted, so when they're not being printed correctly, or it's like stuff like that. He used to always kind of boast about that, and he kind of turned around and said, So I kind of asked him, like, "What's your advice?" It's if I want to carry on my path and kind of do the sort of stuff that you're doing, what can I do? And he says, well, first of all, find a good university. Then once you've done that, stick to it and work hard. And say, okay, that makes sense. And I went ahead and asked him what university, and said, well, you could go to Cambridge, but if you really want to learn what engineers really like, you need to go to Leeds University. And I kind of went, all right, I'm not going to question that. I'm just going to do it. Just
okay. You didn't just look at a brochure even?
Well, a brochure just kind of showed up one day and went, teach me, please.
All right. Well, that's good. And so, you went, I didn't realize you went to undergrad at a different school. I thought you went there at Essex as well. Or, sorry, at Leeds as well.
No, obviously I was born in Venezuela, and then sort of when we moved over to the UK, pretty much all my family ended up living in Essex, and so there was quite a bit of life in Essex kind of thing before I came to Leeds.
Right. Yeah, cool.
But my real engineering sort of background started when as soon as I moved to Leeds, really. So
cool.
Projects and stuff like that. To be honest, I tell you what, I mentioned this a few times to some friend of mine's. But I tell you, if it wasn't for Farnell, if it wasn't because Farnell was based in Leeds, I would say that a lot of the people that I went to uni with would have possibly not carried on with engineering. I mean, the reason why I'm saying that is because back when I first started university, Farnell used to kind of what's the best way to kind of say, throw away electronics. But they'll kind of throw it away at the university, so they basically kind of get all their old used stuff.
Yeah, it'd
and
be like their dump site
return.
almost, right?
But yeah, pretty much. But they would kind
Yeah.
of they would say kind of as a charity sort of thing, kind of give it to the Leeds University. And I remember that the day that I kind of stumbled across that massive box, I would say you can fit quite a few people in there.
Oh, wow.
I remember kind of, I'm not joking, full of junk. I'm talking about like some really good stuff. I mean,
Like just for like scrap parts, stuff like that. Like you could just
exactly like people will be buying parts, and then what they would do is they just return it. And then the people at Farnell would do is, well, either they'll try and get it sent to the manufacturer for them to check it. But if it's something quite low cost, they just wouldn't bother. Just say, here's a new one, and we'll just keep this to one side. And I think it wasn't until a few years later that I realized that they had a trade counter in Leeds, and what they would do is all the return stuff would go there. The people on the trade counter would kind of go, well, we'll leave it here for a few weeks. If it doesn't sell, we'll just end up putting it into a box, and then after that box build up, they'll just end up kind of giving it away to Leeds University.
Nice.
I mean,
so what kind of stuff though? Like you just find you'd get like reels, or these would be reels of components, or what?
It was just a huge mix of stuff, I tell you. So you would, in some places you kind of find like a massive reel of 10k resistors, 0.1% that somebody's returned, and I don't know why that got returned. It was just too good to be kind of thrown out, so I'd taken that. One of my favorite things, it was this massive siren.
Oh, yeah.
Nice. It's one of those embedded ones, the way you just put power and then you just toggle the dip switches and you get various different sounds and stuff.
Yeah, right.
And the number of pranks that me and my other two friends used to do with that.
Yeah, I can imagine.
It became a mission for us, for example, to try and embed that on every project at university. And so I remember one time, I mean, I'm not kidding, like on the first year we had a project, which is basically, it was a burglar alarm. Most people who kind of go into university either one way or another end up doing something very simple or very similar to that. And at that point we were already experimenting with electronics. We knew what we kind of were doing with transistors. We understood what was going on, and we thought, well, we could blink an LED, or
yeah, we could scare the shit out of the professor.
This thing was loud. I would say about 3 lessons worth of, or 3 different lessons at any one time would send somebody out to try and figure out where that sound was coming from. And it was just, because the thing is, I should probably point out, so the burglar alarm was using ultrasounds to trigger. Yeah. So if anybody kind of went by after a certain distance or a certain speed, I think it was using Doppler shift, so it would have been a certain speed, it would trigger the alarm. And so what we did is, what my colleague Alma did, he kind of put it together and he's just going to put it to one side, and we'll be testing it, and there'll be other lessons going on at the same time, and they'll be complaining about, the sound and everything else. And I remember one time, me turning around and I just finished putting together a little board. It's just a light detector, something very simple, and just kind of driving this siren against that. And I just remember putting it in one side and forgetting all about it. And then somebody came along and opened a box that I just kind of left it there with a battery. I mean, just kind of straightforward. And someone just opened it up and just ended up scaring the shit out of... Sorry, I shouldn't really swear.
It's okay.
It ended up scaring the hell out of what eventually became one of my friends. Not because of that reason, by the way. I doubt if she realized that it was because of, she was frightened by that. I doubt she would have been my friend. But it was brilliant. But going back to the Farnell box... I remember getting power supplies. I remember getting I think it was a broken down multimeter, but I think it was just a battery that was dodgy, or a connector. I can't remember what I did with it, but it was all working. Yeah. Eventually, and
that's amazing though. Like pins. Just like how that kind of stuff can, it's almost like when there's a secondary industry behind. Like a recycling type industry. It's like your university experience was the result of that kind of thing. So that's great. That's really great.
I tell you what, I wish there was more companies who would do that rather than just throwing away the electronics. They just put it in a box and send it out to some, soon-to-be engineers for them to play with. Because the amount of fun that I had with the stuff. I mean, even till today, I'm still going through some of the stuff that I collected that I to be honest, I just kept. It's a bad habit. I'm not going to use.
I think a lot of people can probably identify with the having the boxes of junk at home. I'll use it someday, right? I mean, like,
yeah, I'm going to use this 9-volt battery that's already leaked. But it has a funny connector, so I have to keep it. I can't just throw that away.
Right. That would be a travesty.
Exactly. Until eventually my fiance kind of turns around and says, well, you either throw that away or you're sleeping on the sofa, in which case you end up throwing it away.
Yeah, right. That's when you finally learn.
Yeah.
That's hilarious.
I can't remember how many different projects span from those components. I mean, I think one of my favorite ones. So going back to the light detector one, the light detector one. That was using various parts from that box. I mean, there was a PIC 12 that came from that box, brand new. I mean, the pins were a little bit bent. I mean, that wasn't hard to kind of do anything with it. So just there was stuff like that, LEDs, bi-directional LEDs, and pretty much were able to pretty much even the strip board, even the Vero board came from that box. And I have to say, till this day, I probably wouldn't have had as much fun during university if it wasn't for the stuff that came from that box.
Yeah. So how was it the PIC 12, or like what actually got you into the embedded side, and what were your experiences getting into the embedded side of the industry?
Oh right. Sorry, I should have probably kind of started with that really, rather than just kind of going off final box related stuff. To be honest, though, when I was back in college, I wanted to get into robotics. It was just something I always wanted to do, and once you kind of get into it, you end up kind of you end up kind of having to do a trade off between either going full on digital or full on analog. And to be honest, though, I mean, I have met I do have a few colleagues who've gone and done PhDs in robotics, and they have actually kind of kept both sides, but the reason why I kind of ended up into embedded was because I wanted to do robotics, and two, as soon as I came out of university, the first job I had was just purely embedded electronics.
Right, makes sense.
Which is a local company nearby in Leeds, which basically they just design all the embedded electronics for fuel delivery trucks. So it's not just electronics; they also did mechanical stuff. But the stuff that I dealt with was pure digital stuff. So screen driving, sensor reading, relaying that back into a server, that various sort of stuff. But yeah, it was basically because of the first job that kind of made me get into the whole embedded side of things. Well, really focused my skills down to embedded skills. So it's really all came down to that, really.
Okay, yeah. So let's talk a little bit about it. I mean, so you mentioned fuel delivery. I didn't even know this was an industry before you and I started talking.
It's massive. It's probably one of the oldest, to be honest.
Right. So what is the industry, and what are some of the challenges that you ran into with that?
Okay, so in the industry I worked on, and still kind of on and off depending on contract. Basically, it's all about the electronics that you may need for various different type of fuel delivery. So for trucks, which is what I tend to focus more on, automotive. So if you imagine that you're going to transport fuel from one point to another, you're going to need some sort of electronics traditionally, you're going to need some sort of electronics to actually meter that fuel to kind of see how much it dispense.
Right,
because nobody trusts you.
What I would say is I'd usually think fuel does not want electronics because electronics make sparks and sparks make fuel go boom.
Exactly. That's an ethics side of things, which I'm happy to mention that in a minute, which has been much of my headache in this industry, really.
Sure, yeah.
Well, you'd be surprised. It's not actually the designs to be honest, it's not usually the designs of electronics that causes an engineer a headache. It's usually the certifications that goes with that. That's the headaches. And I remember when I was working on when I was still doing full-time work for that company, we were just getting into ATEX. Sorry, I hope you don't mind me kind of. I'll come back with the whole more about the fuel.
Okay.
Actually, no, tell you what. Let me actually do that first. Okay. So it's one of the things. So in the fuel industry, so yes, you need to deliver the fuel, but quite often you want to deliver to smaller houses. So here in the UK, you tend to have sort of places like farms or small states where they may not have access to gas.
So this is including like heating. This is heating oil as well as other types of.
That's right. So gas oil, kerosene, diesel. Yep. Gas oil and diesel, technically the same thing, but priced and taxed differently and all that.
Yeah. Right. So for heating, but also for farm equipment, stuff like that. Like you're just saying
just in general,
getting the go-go juice to the customers who need it.
Yeah, the go-go juice.
Right.
What is it they call it? It's liquid gold, I think they call it.
Oh, so Texas tea, black gold.
Exactly. You need to get that expensive gold to the customers in a way that guarantees that people aren't stealing, and that's basically the industry that I was kind of going into. What can we design so that we know that the drivers aren't going to steal? Which is
interesting. Okay, so that's just a problem as well. So it's about certifying that. So one way would be like weights. Is that right, or is that one way to handle how? You know that a truck leaves. It's like one of those school math problems. A truck leaves station A with however many kilograms, and then
suddenly the driver is a gram or two heavier than what's the equation at the end of that? Yeah, it's one of those problems.
Yeah, right.
To be honest, though, when it comes to metering, there's various different ways to do it. But surprisingly, the one that's traditionally done so now is literally just slip gears. Or it's essentially just you've got some gears where the fluid is trying to kind of push through and rotate those gears as basically essentially causing a metering sort of causing an encoder to count how many cycles essentially those gears are doing.
So is that like you mean like on the outflow? So like as fluid ticks past a certain point, it's saying, oh well, these gears have ticked 5 times, then that equals 4 gallons.
X amount.
Yeah. Okay.
And compensate for X temperature and whatever flow rate you're on, and so on and so on.
Oh yeah, because I guess if you like any kind of liquid has different expansion characteristics, stuff like that, right?
Yeah. So temperature compensation became quite a big thing about 5 years ago. I think I don't know about the USA, but here in the UK, you pretty much anywhere you go, you're going to see temperature compensated. Actually, even on the fuel cards, you end up finding that when you kind of next time you come to put fuel in your car, have a look to see if you can find that 15-degree sticker that tells you the fuel's been compensated to 15 degrees. So yeah, it's kind of became a big thing back in I'd say about 5 or so years ago.
So what? It's standardized on 15 degrees as like the standard coldest kind of. Well, that's not true because it wouldn't be coldest. It's just a standard.
Well, what it'd be is like they're trying to figure out how much energy they've basically charging you for, and so the way to do that is regardless of what temperature the fuel is, you bring it back to a known temperature, or you bring it back to a kind of standard temperature. And so it kind of like if you imagine you'd be surprised how many fleet managers are a bit quick with the trigger kind of thing. You imagine if you're kind of delivering fuel when it's cold, by the time it gets to the customer, it may not have the same energy. It's going to be more dense, isn't it? So you're actually delivering more fuel when it's cold. But when it starts warming up, the fuel's going to expand, and therefore you're going to be delivering for the same area. You're going to be delivering less energy.
Oh, I see. So if you had a very tiny truck and you put a gallon into it, but the tank could hold 2 gallons, you're saying, and then it heated up, that when you meter it back out, when you're pouring it back out into wherever it's being delivered, if you measure out, you say, oh, well, I'm going to give you a gallon, there could still be some remaining in the tank. That's the idea?
Exactly. And then you ended up finding that quite a few sort of smaller fleet companies or smaller fuel delivery companies would take advantage of that. They will basically try and see if they can... because when they introduced the whole temperature compensated thing, you were actually the drivers were actually able to enable and disable that feature. So it kind of became a bit of an annoyance, really, because some less honest people would go and enable it during the winter time and disable it during the warmer times.
Oh,
so that way they always gain. But because the theory was always that if everybody wasn't temperature compensated, then it should, in theory, average out across the year.
Right. I see. Right. Yeah. And if you're always from the same delivery people, that kind of thing. That's interesting.
Exactly. But as they slowly started introducing the whole temperature compensated side of things, you ended up finding that some people are trying to, you get customers kind of saying, is there any way we can disable that at will? It's like, yes, but that's not morally right.
Right, yeah.
But that said, there's now become a thing now. So national weight measures, which is now, I don't know what it's like in the USA, but in the UK, national weight measure basically turned around and said it has to. If you're gonna have it on, it stays on. If you're gonna have it off, you have to have it off.
Yeah, right. That makes sense. So a little bit more about the actual logistics here, though. So like when you say, when I think about tanker trucks and stuff like that, I think about the ones that I see around the U.S. at least. Like mostly
the big rigid ones, aren't you?
Yeah, the ones that are going to gas stations that are like basically going to fill the tanks there. You're saying that these are more home delivery, like smaller trucks that go to
smaller trucks.
Houses?
I mean, I do also deal with the larger ones as well, but for the actual electronics, most of the trunks that I designed for actually went for the smaller ones. But there was a reason for that, actually, because for the larger ones, like the ones you're used to, usually you don't tend to have power on the back other than the tail light and indicator light kind of thing. And so usually if you try to put any electronics over there or in the back of those larger vehicles, you have to have some sort of battery method to try and kind of get rid of it, or trying to power your electronics. And so for a while, when we started releasing products, or when I still worked at the place, when we were releasing products, we kind of stuck them. We kind of ended up focusing more on the rigid or smaller ones, just to make sure that we got all the electronics working and it's kind of proven technology. And then eventually we would move on and kind of introduce battery power one. And so like the truck that you're kind of used to seeing, those tend to kind of fill up completely and discharge completely, so they don't tend to do smaller drops, if that makes sense.
Yeah, I guess you wouldn't need metering so much as like just put everything
and then
where you're going, right?
I know this is the case in the USA because I do have some dealings with America. So what they do over there is that actually the fuel is actually owned by the customer. So the customer is not. So let me kind of take it back a bit. So ordinarily here in the UK, what tends to happen is that you pay somebody to deliver this much fuel for you. So you're actually buying the fuel of somebody, and they will take care of the logistic to get that to you and dispenser and so on. In America, the way it is actually they already bought the fuel. The customer already owns that fuel, and they're only paying you to go and pick it up and drop it off. And so what ends up happening is you end up getting like kind of like either one guy who happens to own a truck, he'll get paid and do the fuel delivery kind of thing, or you will end up paying kind of like a smaller, or I'm not really sure how distributed it is in America, but you end up paying like a fleet driver, sort of like a company who has a fleet of people who basically own the trucks, and they're ready kind of to do the delivery for you.
And then it's like a charge on top of the actual fuel cost, that kind of thing.
Yeah, and so the issue they have, which is kind of the reason why we started going into that market, is that what happens if they've gone and bought a full truck full of fuel, and the driver's gone over there and went to deliver it, but it's a frustrated delivery, so there's like 1,000 gallons, whatever it is, that they weren't able to deliver. What's the driver do with that fuel now? Because in his point of view, he has to go back and pick up other fuel for other customers. So what is he going to do with that? And so we started kind of going for is we're basically taking the product they already had here in the UK, and kind of give them a way to kind of measure that and send that information back to their original customer, so they know this is how much fuel you got left. And so this is how much you could potentially get off this fleet driver from, next month or next week when you actually do have the space for it, kind of thing.
That's interesting. It's almost like liquid accounting, like there's like entries and there's, withdrawals and entries and that kind of stuff. But yeah. And I was just thinking about it too. This does exist in the States. I mean, it's my wife's family is from the country, and they do, I think it's propane heating, but
sorry, I have to say propane.
What do you say?
I'm trying to do the King of Hill thing.
I don't watch that show.
I'm sorry, that was bad.
Was it supposed to be Bobby? Is that?
All I'm gonna say is I'm sorry, guys. That was really bad.
That's fine. I don't know what the delivery or what kind of actual gas it was, but yeah, I mean, this is. I'm sure this is existing in a lot of places where there isn't infrastructure for piping, natural gas or other type of fuels around. So it's very interesting.
I mean, my sister lives in I think it's somewhere in Kansas. They have a massive tank of their own, which once a week or once a month, however long.
Yeah.
They get somebody just to kind of top them up. And that plenty of people live like that, and it doesn't seem to be an issue. I mean, it's nice to actually have gas coming straight to your house because you're not going to be worried about running out of fuel during winter.
Right.
But to be honest, it's actually going to be cheaper for you to actually buy the fuel yourself and store it.
Right, because of contracts, stuff like that.
Yeah.
That's interesting. So let's talk a little bit more about the instrumentation itself. I mean, so you mentioned, so is it mostly flow metering, or is it weight, or how I mean, or you mentioned those gears as well. So what are some of the methods for, just even measuring liquid in general, right? Because that's kind of a broader term that I think a lot of people would be interested in for kegerators, stuff like that.
Well, there's quite a few different ones. I mean, I can tell you the ones that I had the experience with. So the standard one, which seems to be the sort of the norm here in the UK, is the flow meter, and that's the one using I forget the name of it. I put it up. I'll send you a link to that later.
Okay.
So essentially, it's two sets of gears that kind of are acting against the flow. So the flow itself is kind of rotating those gears, and you've got the
I kind of think almost like
that one.
like a windmill or something, or like a turbine almost, where you're kind of spinning the turbine.
That's the other method. So that's another method. So using a turbine.
Okay.
Yeah, there's a difference. So this one, you literally have like it's you know what? It's gonna come back to me after the show. I'm pretty certain this is really bad. So where this one is basically, it's kind of like a flatter set of gears, usually two, and essentially you're basically trying to put pressure against these gears to rotate, and basically assuming that there's no slip. You can measure pretty accurately how much fuel you pump through.
Okay,
the turbine.
It's more of a, so the flow meter is more. I'm sorry, there's a lot of noise here. The flow meter is more about kind of measuring or having a known, as you apply pressure to these gears, it creates motion, like a certified motion type of thing almost.
Yeah. I mean, where with the turbine, as most people kind of tend to picture with a turbine, you literally just put fuel through this turbine and it starts rotating, and the number of revs you get equates X amount of fuel.
Right.
And so with that one, there's a couple of issues you tend to find. First is you tend to get slippage. So you get product kind of going around the blades themselves. So you need to kind of have like a very tight gap between the blade and the outer walls to make sure that none of the fuel kind of escapes through that. Because the problem is, if you've got fuel kind of going through the blades, going through the turbine, if you've got quite a few of them kind of quite a bit of liquid kind of going around the blades or kind of escaping between the blade and the outer walls, you're not going to be able to measure that, and so that could potentially add up to X amount of error, many liters worth that you're not really accounting for. So that one tends to be a bit difficult to deal with, and usually when you end up buying those sort of turbine meters, they tend to be quite expensive because there's a lot of good engineering that's gone into that to kind of guarantee the workings of it and the lifetime of it, and all that sort of stuff. But once you get it right with those ones, you tend to have very little errors later on. So like with the first one I was mentioning to you, that one needs to be at least calibrated once a year. I mean, to be honest, if you're delivering any fuels here in the UK, all the meters have to be calibrated once a year anyway, so it's a requirement. But so as far as
that's like government mandated type thing.
Yeah, that's National Wet Measures requirement that you have to calibrate it once a year, and you have to have a certification for that. You have to have a seal to kind of prove that nobody can tamper it, and so on and so on.
Right.
And
I've seen those at U.S. gas stations as well. Usually there's a local commission that does that same kind of thing, where it's just like it's certified. I always wondered if it was more of a, that's how they make part of their money type of thing as well. But it's also probably protecting consumers, that kind of thing, right?
Yeah, I'm sure it's a bit of both. To be honest, though, with most certifications, people are going to want to make money, and I'm pretty certain. Like for example, like with if I tell you that, like the third one, for example, of a way of metering, using ultrasounds to actually measure the flow. In fact, Mike, he did a video, a teardown video on a gas meter that uses ultrasounds. He put it up on YouTube. That sort of method is far more accurate as long as you can assume that you can remove all air bubbles in the liquid. And when you think about it, that that shouldn't really need any. That shouldn't have any wear and tear. So
exactly. Versus a mechanical type thing. Could you explain that a little bit more though? So is it like you? Well, I don't understand the actual measurement.
Oh, okay. Oh, yeah.
Of ultrasound.
So with the ultrasound, so what you have, so if you imagine you got yourself a pipe, and you need 2 ultrasound sensors for this to kind of accurately measure the flow rate. And so what you do is you got sensors lined up so that when one pings, it pings with the product, in the direction of the product's flowing, bounces off the walls and hits the other sensor. So basically when one sensor is pinging, the other one is reading the pulse that is sent.
Okay.
And so
they're facing one another. Is that the idea? So it's like kind of like a crossing a laser line type of thing.
No, they're more. Usually, what tends to happen is that you tend to kind of have them mounted on one side of the pipes, and the same side of the pipe bouncing off the wall from the other side of the pipe, and kind of following the pipe along. So usually, you tend to have kind of reflectors to kind of have like a 2-point contact on the actual pipe. So kind of directed to the other sensor. So you wouldn't normally kind of face them together. You tend to kind of try and... The idea behind this is so that the actual ultrasound ping is following the path of the liquid, at least for X amount of distance. Okay. So are you getting that so far?
I think so. Like it would be like an almost like an angle. Like you'd set up so it's in the direction of the pipe, but it might be angled at like not directly along the pipe at 0 degrees. It might be like 20 degrees off, and then you put a reflector, and then you put another one 20 degrees back, that kind of thing.
The key thing with these sensors, with the ultrasound sensor, is that you actually want at least X distance where the ultrasound is traveling with the liquid. If that makes sense.
Yeah, I think so. I think so.
So the idea is that if the product is flowing in one direction, you ping from one sensor, and then you ping the other sensor going against the liquid, and the difference between the two will give you the flow rate.
Oh, okay. So it's like a time of flight type of measurement, or what?
Exactly. So like with lasers, you do the same thing with this. So you measure the time. Sorry, I should have said you measure the time the ping takes to get to the other sensor, and by pinging both sensors, with and against the flow, you can figure out the flow rate. So with Mike's video, he did a pretty good job kind of tearing it apart and kind of showing you how that works for a gas meter. But the same principle works for fuel. So assuming there is no air bubbles in the actual liquid, assuming you can pretty much get rid of that, or at least minimize it to a point where it's not too much of a problem, you can very accurately measure the flow rate of the fuel. And now if you know the flow rate and you know what the density it is or what the product is, you can work out how much that's flowing or how much you've actually metered through.
Yeah, right. So let's talk a little bit about the... so it sounds like, first off, these sensors... So like you buy like kind of like certified completed sensors, you buy kind of more raw sensors than you do the calibration.
Oh, right. Is this for the meters in general?
Just in general. I mean, like, is it... Because I've had situations before where like I've been using sensors where it's like you have to buy... You buy a fancy sensor with a certified output, or you buy a raw sensor and then you make the certified output. Ah,
right. I see where you're getting at. Yeah. So, like for example, for the stuff that we did, so with the first one that I mentioned, that's the one with the gear stuff. The company I work for, they just buy basically all that what is just an encoder, a quadrature encoder. You just buy that, and what you're paying for is the quality of the meters, quality of the gears and stuff. The housing and stuff. Yeah. And so you know that's gonna have X amount of errors and so on.
Right.
And then you design your own electronics to basically read from that and do your calculations, and you basically display that.
Right. Yep.
But for the company I worked for, they were buying that already made, that side of things. So the official national measured certifiable product, they'll buy that in, and then what I was doing is designing the extra electronics to basically anything that he might need. So, like for example, I was mentioning the air bubbles in the liquid.
Yeah.
So I would have designed the electronics to guarantee that we know when there is air bubble, and if there is, then open X valve that would allow for the entrain air to be removed and so on. But that was just one aspect of it. So yeah, you could actually buy those already, those sensors, the meter and the driving electronics, and you got yourself pretty much a certifiable product. But then there's the second part that you need to deal with, and that is actually getting it certified.
Yeah,
Because
right. Yep.
because you can't just go there and just put it together and say, yeah, this is going to be fine. We're happy that's going to work. You actually have to go back and first get your product approved by National Weight and Measure, and obviously meet their requirements.
Right.
And then once you've got that approved, then you need to also either have approvals for you to certify your equipment, or you pay somebody to calibrate and certify your equipment. And it's like, oh, okay.
Yeah.
It's that there are just so many points of certification kind of thing.
Yeah. Yeah, I guess the thing I think about is, so like I used to do industrial, and it would be like you could either have someone who wanted to use, they could use, so in industrial there's like 4 to 20 milliamp type communication stuff, but then some people, some people would also do, they would actually want to use like plus minus 10 volt input and then have like a raw sensor kind of thing. And the 4 to 20 is almost always, like a hockey puck module thing that has some processing on it externally, and that's just sending back that current signal over the line. So that's kind of my experience with that kind of thing, where it's a lot of times these days it felt like more people were just buying the hockey pucks. They were already certified to a certain spec.
Oh, yeah.
And then,
because to be honest, though, it takes a lot to get stuff certified, to be honest. I mean, that same company, I mean, there's two products that I can mention. That the same company did a separate product altogether, and it wasn't sold as a metering system, it was sold as a gauge system. And so
what's the difference?
So the difference is that one of them you can sell by, and the other one you use it for like stock checking or to verify how much you've got in a truck.
Oh, okay. So meter is actually certified.
Yeah, so the meter will be the one that you use to sell to the customer. That's the one that you say, well, we've given you 10 liters, so therefore pay us that kind of thing.
Right. Yep.
I should say 100 liters because that's the minimum most of these trucks tend to do, or they're allowed to. The other one, which is a tank gauge system, that was actually a sensor that sat inside the actual truck itself, and that one measured the product directly and told you how much you actually had inside the tank.
Right.
And so that one uses pressure sensors. So there's various ways you can do this. You can actually measure the actual static height of the liquid. But the way this one worked is that you had two pressure sensors, one which is pretty much sat right at the bottom, and the other one which was precisely 200 millimeters apart from the other one, precisely within tolerance, obviously, because you calibrated it out.
Yep.
And so the point you made there about buying already made sensors or already made calibration sensors, it's a big difference, because like for the stuff we were doing, we were trying to push the technology we were buying in. So we were having to actually recalibrate the sensors to try and get that optimum, reading, because the stuff we were buying in. But basically, the issue they were having at the time was that they wanted to have a low cost alternative to what the other people in the industry are doing. Like there's companies in Canada, for example, which they're using ultrasounds to measure the product, the height of the liquid, and their system costs many thousands of pounds for, I think, like 10, 20 grand. So the objective of the company I work for was they basically wanted to have a system that would cost no more than a few £100 or a few £100 or so.
Yeah.
And so having to calibrate your own sensor actually ended up being a need, because we were buying in what seemed to be relatively cheap sensors, pressure sensors, which were technically classed as calibrated. And so we'd taken that and we'll go ahead and, I built a whole test rig and a whole pressure chamber and everything else, and temperature compensation and all that stuff. And, it's a pain trying to kind of like calibrate every single point and trying to compensate for various different problems from the sensor. So things like, for example, you wouldn't really think about it, but a resistor, it will change its value based on temperature.
I used to think about these things all the time, man.
Oh, right. Sorry.
Yeah.
So yeah, like little things like that. It's like it made a sense. But the thing is, though, when you buy calibrated sensors, you really, really have to pay attention to what the manufacturers tell you what you're going to get from it.
Yeah.
Because they'll tell you you can talk to a sales guy. I tell you now, and this has bitten me a few times. You can talk to a sales guy, and you will ask them directly and say, "Is this good for XXX?" They'll go, "Yeah, you can do it. It's fine.
Why not? What's the big deal?" Right, exactly. Right.
You come back a week later and you go, well, hang on, I just looked at your data sheet and just checked again, but that doesn't make sense to what you're saying. Oh, yeah, well, we calibrated to X amount, and to guarantee that we can sell enough sensors, we always calibrate them better than what they really are. So you can actually do what you're saying. It's like, no, you can't, kind of. If you're having to sell the sensors and you're having to kind of, you're gonna calibrate them at order of magnitude better, aren't you? But you can't expect that to be a realistic value.
Right.
Right. Anyway, so I can appreciate having to actually buy already calibrated sensors.
Right.
And I tell you, if you can, do it.
Yeah. Right. So what about on the so on the output of these things? So you were obviously building embedded systems around these. I mean,
yeah.
In terms of outputs and handling these sensors, what did the systems look like?
All right. Well, the industry standard, the industry standard for automotive is CAN, and so basically, pretty much anything that we design would one way or another end up outputting data via CAN.
Right, and we were talking about that last week with Mike Osman.
Oh yes, you were.
Hacking in getting on the CAN bus, that kind of thing. So
yeah, although interesting enough though, even though you could potentially, even though we worked in the automotive industry, even though I worked in that industry, you don't often tend to connect your CAN system onto the truck CAN system, for example. You only do that if you had to. If for some reason some customer said, "Well, we already have a system, sniffing data from that, so please connect it to that."
So you're saying it's more about having a standard than actually being hooked into the larger bus.
Exactly, because the thing is that the one of the nice things about CAN is how easy it is to create nodes from it, or how easy it is to kind of split processes. So, like for the smaller rigid trucks, you may have like 5 or 6 different compartments, and so you may have like one sensor per compartment, and each one may spit X data, and so having a modularized, having a CAN system that supports multiple nodes, it's a must really, because you can do all sorts. I mean, you can have a sensor reading from the truck, then you can have a node relaying that information back to the driver, and you can have another node send that data back into the headquarters. And
does that make it more extensible then too? Because you might have one truck that has 5 compartments and one that has 10. Is that kind of the idea?
Exactly. So that was actually one of the major driving system for us to go into CAN, because one of the alternative we had with one of our competitors, he was literally trying to shoehorn RS-232 to actually do that. And I know you can put transceivers and make the RS-45, I think it is.
Yeah, that's a good standard. I like it.
Yeah, so you can try and do that, but that's not what he was doing. He was literally having to kind of have microcontrollers per per hub. So you had X sensor sending RS-232 to a node, and that node was reading from various sensors because he had like 5 different serial ports. And
ooh, yikes! So it was kind of like a hub and spoke versus having like just a string. They're all kind of on a string.
Yeah, I mean, there were some advantages to that because, like with the ATEX side of things I was mentioning, I think I mentioned this to you before. So if you're going to work in this industry, you have to be aware that you can't just stick your electronics into these trucks and hope that everything's going to be fine, because if there's a spark, someone's going to die.
Right.
You're literally, the drivers are literally driving a time bomb. You know what I mean?
Yeah, right, exactly. Yep.
And like with most standards, the ATEX standards, what you want to try and do is make sure that you've done everything right, so you're not the guy that's been blamed for what something's gone wrong. Right. And basically what ATEX standard is doing is kind of defines things like what can you have, what sort of materials can you have exposed in this environment, what sort of electronics can you put in there. If you are going to put electronics in there, what sort of protections are you going to put in there? Are you just going to pot it and hope that that's going to be enough, or are you going to have some sort of flame-proof enclosure? And so basically the standard kind of controls exactly what you can do or what you can and cannot do with the electronics. Actually, to be honest, it goes as far as actually even the clothing the drivers can wear.
Really? Wow.
So it controls everything. It's not just the electronics. It controls what the employer gives to their employees, what sort of notice, what sort of billboards and labels and you know what I mean, you can have in the office to make sure that people are aware that that's going to be explosive.
Wow.
And I mean
that's really, I mean, yeah, and it's for a reason, right? I mean, that's just for safety and stuff. So
well, that's the thing though, enough people have to die before stuff like this happens, so it's
sad but true point. Yeah,
it shouldn't happen, but eventually we got a standard that actually helps prevent issues.
Yeah.
But the problem I was having, right, when I first started out with Atex, the company I worked with, they never did Atex before. They were saying, we're going to go into this. I mean, I should probably point out that if you're delivering kerosene or gas oil, something like that, because of the temperature range that we tend to have in the UK, it technically doesn't actually fall within the ATEX round of things. It's more of a, if the customer wants it, they can request it and enforce it, but it wasn't a requirement. Or at least not until recently anyway. And so at the time, we were able to design our electronics, and as long as we can prove that the electronics were going to be powered off during a hazardous situation, then you can stick whatever you wanted there. So very quickly, I mean, it didn't last long, but the company went straight away to, okay, we got to go to ATEX and just guarantee that nothing's going to happen and so on, in case for some reason the driver decides to turn the system on. Too many, you want to remove those variables kind of thing.
Right.
And so one of the interesting things though is that when the company wanted to go into ATEX, they didn't just went ahead and say, okay, let's just bring somebody in who's done it before. Tell you what, let's get one of our engineers and just throw him in the deep end. Let's just give him the standard and hope for the best. And that's what happened to me. They just kind of, they just kind of like, it was kind of like just one morning say, okay, it's official. We're going to do this. We're going to force it. And from there on, I just got given a copy of a standard because my boss went off and this is before I joined. They had a meeting with some company who was trying to kind of sell them their ATEX services, and they bought the ATEX standard at the time. It's like an EN number.
Yeah,
and then
I'm sure a lot of people could identify with this. Like having to do other types of ISO type standards, stuff like that. Just being handed a standard, being like, now you have to parse all of this and figure out what we need to do, that kind of thing.
Yeah, and to be honest, that really does tell you a lot about the person, though. Can they handle it? Are they going to break? Are they going to make or break?
Right, exactly.
I'm not kidding. I was working with this colleague of mine. He's probably going to be listening to this. I don't care. That day, right? So he finally joined and everything else. And I said to him, look, I'm going to do the same thing that was done to me. But I wasn't going to leave him on deep end. I was just kind of trying to see what's going to happen. And I just gave him the standard and said, look, read it, memorize it, do your thing, and do your electronics. If don't worry about it. When we go through the certification process, we'll all be around. But this is down to you to get it right.
Yeah.
And he didn't take it well. In fact, there was. Let's just say that his career could have ended at that point. At least with that company, anyway. But that said, though, because I've been friends with him for years and he knows what I'm like anyway, so he kind of eventually realized what I was trying to do there. It was more, look, you just joined. I should probably point out
trial by fire, basically, like just trying to.
Yeah, I mean, I should point out that I managed to get him the job at the place that I was working because we needed somebody quickly, and then he just finished off his PhD or he was just in the process of kind of doing something else altogether. And I kind of went, well, I know you don't have any skills in electronics. Don't worry about it. I'll help you out. I'll mentor you. I'll teach you everything you need to know. And, you'll learn by experience. And then like the very first week, I'd say, here's the certificate. You learn, right? You start learning through this. You memorize like if it was, like if this was your only way to live kind of thing. And it was, you know what? I can't say that we should do this to people, but it's amazing to see their reactions. But please, if you're going to do that, just bear in mind that you have to have some compassion and tell them eventually that actually you're just testing them. You don't expect them to actually do it. But right. He eventually handled it quite well anyway. But
that's good. Well, I was just some more about the interfacing with the systems. I was wondering more about.
Yes.
So you mentioned CAN bus, but then actual interface like off of the sensors, was that mostly like parallel serial interface type stuff? Was like I2C or what did that usually look like?
So the sensors that we were buying in were digital, so they were I2C. So you design your board to connect directly to it as close as you can, kind of thing. And you take the sensors because they were being sort of calibrated.
Right.
And so you can take that information. You get your microcontroller, which at the time I was using an ARM processor, the LPC 11C14, I think it was, which was quite convenient because it did everything you needed. Like you can read from I2C, and you had a CAN peripheral in there, so you can send the data straight away, kind of thing. And so basically the objective was at that point is to read your sensors, your two sensors, because I think I mentioned that there was two pressure sensors in there. You take your readings. You do your next calibration process, or whatever it is that you had to do to calibrate, whether that was temperature compensation, which was at the time. Take your reading, you convert that to a known value. So at the time I was doing like kilopascal kind of thing.
Okay.
And then I was basically taking that and then working out what the height of the product is. Because the thing is that because you got two pressure sensors in there, you know the distance between the two. So you can take the pressure difference between the two of them and work out density.
Right. And so you're saying, though, that you want to send back that calibrated value to some other node then? Is that the idea?
Exactly. So once you got that information, you can put it through the CAN. And some other node could be a display screen, for example, which another thing that I had to develop. And that would display the information. It will tell the driver things like, you're carrying kerosene, because we had density. You're carrying kerosene. You've got X amount of product because we've measured the height and we got density, so this is how much you got left.
Okay.
But the thing I should point out, like with trucks like this, though, you can't just go ahead and take height and take density and here you go, you've got yourself a volume, because inside those trucks aren't perfectly round, if that makes sense. They tend to be kind of like made out of baffles, like curved walls.
Right. So you can't assume some uniform shape, basically.
Yeah, it's not going to be linear, or it's not going to be predictable enough anyway.
Right.
So you have to have a second set of calibration that takes your pressure and convert that to volume. And so that's
interesting. Okay.
So it's quite an involved system. But the point is that because you're using pressure sensors and you got yourself a really relatively cheap interface CAN, you can expand it to do whatever you want. So you don't have to just put pressure sensors in there. Like the most recent product that was released had color sensors, so that's where I basically took a color sample of the product, and with that, because I should point out that there's multiple products that have the same density, but it's just their color that are going to be different, and so it's hard to tell. Yeah, it's hard to tell if you're carrying diesel or gas oil if they're quite close to each other, if their densities are really close, if not the same. They are technically the same product. So like one in the UK is more like it's a bit more yellow, the other one is a bit more brown, and so on. So you can take that color sample
and so what did you need to? So that's actually that's a good idea, the color sensor idea. But what did you use that output? So now you know it's diesel versus being kerosene. What is that just for an information type thing? Like you're carrying just as a verification. You're carrying diesel.
Well, the thing is though, is like going back to what I mentioned to you about the calibration output, so the volume output, you actually be able to use that to tell the driver, one, what you actually carry in, because one of the things that they have to do is, because one of the things that you don't want to do, because unfortunately the way the trucks have been designed is you could actually accidentally load on top of another product that probably isn't the same product you're trying to load on.
Oh yeah,
and so,
yeah, that'd be bad. Right, because that would basically make it a big tank of uselessness, right, if it's mixed together.
Yeah, and believe it or not, there's a huge industry around around what happens when you do actually mix two products, and an industry where they actually go ahead and try and recover as much of the product as possible.
Interesting.
By splitting chemical wise. I'm not really too familiar with it, but
no, that's amazing that if there's an industry for it, that means it probably happens a lot, right?
You'd be surprised, and it might not necessarily happen a lot. One of the things that actually can happen is like in the actual depot themselves, the places where you're doing your fuel delivery, you tend to have like small amount of spillage anyway. So when you're connecting and disconnecting connectors, or you have a little bit of waste here and there, what they tend to do is they tend to funnel all that to one storage tank. So because they can't just throw away the waste into some sort of landfill and hope for the best.
Right.
They tend to just collect it. So the industry not only does it deal with when people had accidents, but they also deal with actually trying to recover that waste, trying to split that up and try and get as much of it as possible.
Yeah.
And so it's quite interesting though, because I've seen the electronics that got in there. So it's like you actually have various different sensors running on that, trying to get that information. So what is in there? Is this purely? Is there water in here, for example? Can we remove that straight away, kind of thing? But so yeah, it's not just purely for accidents, but although that said, I do remember a colleague of mine. Because when you want to test these sensors, these pressure sensors, you got like a hose that you connect from the side of the truck, and you can plug that back into the truck, into the compartment. And what he was doing, he was taking out from one tank in the same truck and moving into a different tank. But what he failed to realize is that one of the tanks, I think he did realize, but he just dozed off kind of thing. He failed to realize there was already X amount of products in the tank, what he was filling into. And so he figured, I got 5 minutes, I'll just bugger off, quickly do something, come back. He left the truck unattended, and when he came back, there was just fuel being spilled from the top of the truck. And
yeah.
He wasn't. We didn't let go of that for a long time.
Nice. Yeah.
It wasn't too bad, by the way. It was kind of like a safe area. They did manage to recover all that fuel anyway, but
yeah,
it was like
no, because that's a good point. There's just a lot of money in that too. So that I would imagine that helps, also sell these types of products, because you can quickly say, oh, well, this will save you money because you're not going to, obviously you're going to measure stuff, but also you're going to know what's in there. You're not going to ruin stuff, that kind of thing. Anytime you have a product that's going to save people money, they're usually pretty ready and willing to buy that kind of thing. So
yeah, I mean, it's surprising how many little industries kind of spill off from that sort of stuff. So it's good for people. It's good for people. I mean, to be honest though, I would hate to kind of see that sort of waste product that's been put to one side. It's bad enough that we throw away electronics all the time. Yeah. It's just to sort of see that sort of crude oil that's kind of been mixed with all sorts and crap, and don't let it go to waste.
Right. So any other big challenge? I mean, so obviously there's the sensor interfacing, there's the connecting nodes together, that kind of thing. Did you have like a master node for that kind of thing? For like on a CAN bus, is there a master node, or how does that work?
No. So you can if you want to. I mean, it depends how you design the code. But sort of like it's raw, sort of like as this basics kind of view, as basic setup. You basically every sensor will have its own unique ID. Yep. And basically the one with the lowest bit value as for the ID wins. So if you got multiple nodes set up, you got sensor A, which has ID 1, and you got sensor B, which has ID 2. Then the one with the lowest number, the one with the lowest recessive, I think it's recessive. It's been a few months now. Ends up winning the communication. So if you have two nodes trying to talk at the same time, then one ends up talking. And then
that we did something similar with RS-485, and there's a reason for that, isn't there? Where it's like you're like XORing the
exactly. So
ID numbers or something.
That's right. So what happens is that all the CAN devices, all the CAN nodes are in sync together. So they all start talking. They're all basically, whenever they're going to talk, they wait for that start sync, and then basically they start pumping out the bits together. And the one with the lowest zeros or the most zeros, basically by the time they finish pumping out their ID, they end up reading it back and seeing, okay, is that my ID? It's not. Okay, let whoever else won do their talking, and then I'll try again in a minute, or however long you will leave it to.
Yeah.
But you'd be surprised though, if you don't design it correctly, how easy it is to overcrowd the bandwidth. So, for example, if you got one sensor who's sending data every millisecond, or however quick you've got the CAN set up, if you don't give enough time for other nodes to talk, then you can quite easily stop, or you can quite easily kind of essentially span the network enough so that you can't read from other sensors.
Because the lowest sensor, the lowest node number is basically flooding the system.
Yeah, and it's always coming back straight away, especially when you've got similar architectures all around the truck using, like if you imagine using the same processor and they're running the same code and they're virtually in time together kind of thing, you're gonna, when they all kind of try to talk and then they'll go away and then they'll try and talk again at the same time, again that one sensor keeps coming back. So one of the things that I did for the first for the first node system that I had kind of set up, I had a master and slave system. So it's completely down to software at this point. So what I had is like they'll all be listening to one particular ID, like a global ID. And when that gets sent out with whatever data I've sent out, they all kind of straight away look at that and send their information.
So it's like a broadcast packet almost?
Yeah, precisely. Like a broadcast. It's precisely that. And so the way I had it set up at the time, like the first time I designed the hardware for this, I would have it like every 500 milliseconds, I'll sample the network. And so any data that I want to read from all of them, they should be able to come back and send their information within 500 milliseconds before I do the broadcast again. But the reason why I'm saying that you have to be careful is because when I came to the second version of the system, I wanted to go for more of just send your data once a second, we'll see how it goes. And so what would happen is that the way the code was set up is that it would try to send the data. If it can't send the data, it will just pull back and just leave it, and we'll try again next time around. And so what will happen is if they're all been set up to send data once a second, because I stupidly wrote the code so that it will be basically every second, precisely every second, there'll be an interrupt asking for the data to be sent. You basically had like one sensor talking all the time, and the rest kind of going, I can't talk right now. We'll just leave it.
Right, exactly. Yeah.
And then next time, it was. I mean, you can set it up so that the hardware peripheral itself would automatically resend the message. But at the time, I didn't bother with that. I just kind of wanted to kind of control every aspect of it and let me decide if I want to retry and let me see what the error is. And yeah, that very quickly.
Yeah. So two questions. One is, first off, how do you actually set the node numbers and those kind of things? Is it like a jumper, or how do you do that?
You know what? That's actually one of the hardest thing to do when it comes to deciding, when you have to assign an ID to something.
Right.
It's quite a hard thing. So what I went with at the time was that basically you plug in one sensor at a time and you send it a master ID, which is the same for all of them. Like for example, the same broadcast ID that I would have sent out to tell all of them to sample.
Yeah.
I would have used the same ID to tell it, here's your new ID. And so I know it kind of sounds a bit cumbersome, but basically you had a master broadcast ID that could override any of the settings from the other ones with whatever ID that you wanted to have. And so the idea is that when you go into production, you plug in one sensor, you power it up, you set the ID, you disconnect that, you plug the next one, and you just do that.
Okay. So you just have to put them on the network, talk to them, and tell them what they are. That's the idea.
Exactly. Now we can get away with that, by the way, because usually what tends to happen in this industry is that you design your kit, you put together your kit that you're going to send out to a truck to be mounted onto a truck, to be fitted to a truck. I mean, and so what you would do at this point is that, okay, let's leave them all set to the same ID, because the customer, which is the people who put together the truck, they will have to put one by one anyway, and they'll just set the ID because they're having to connect the physical sensor in. And so what I ended up doing, it's just a sort of like a second thing towards it, is that once you've got an ID set, from now on, you have to stop talking and you have to enter your power out after you have to enter the power cycle to get back into the network.
Yep.
So basically, all I did at the time is save the end user or whoever it is that's setting it up an extra step of disconnecting the sensor and plugging it back in. So basically, the fitters will go in there, put a probe in, connect into the network, set the ID, and then the probe will automatically disconnect. But just basically waiting to power cycle anyway, and then you plug in the next one and you just kind of follow the flow.
Right. Yeah, because you want to make sure that you also don't assign the same number to two devices in the network, that kind of thing. Because then
be surprised how often that happened.
Yeah. Right.
Because you'd be surprised because you have one guy coming along, plug in one sensor, and he'll disconnect it and go, oh, but did I set that correctly? And they'll plug it back into the network and go, no, wait, no, either you leave it on or, oh, no, don't.
Right.
So
that's a tricky problem for sure. And I know I've heard some stuff about like wireless networks. They have an even harder time because with wireless, you don't have the opportunity to power stuff down and have like physical connections and say, okay, well, this one's plugged in the network right now. I know I'm talking to this one. When it's wireless, it's like, well, if it wakes up and it's on and it's trying to communicate, then you got to kind of broker who's going to be who, and then you have to do some kind of weird naming, like just kind of picking a random ID or using a unique ID chip on board, that kind of thing.
That's right. I mean, I've seen some people use one-wire devices to basically, because they got unique MAC IDs and they'll just use that.
Yeah, I've used those.
Incidentally, the device that I mentioned, the LPC11C14, virtually all NXP Quartus M0s, as far as I'm aware anyway, I think it's the same for the M3 versions. The NXP have dedicated MAC IDs in them, so they will be unique. So I could have used that.
That's tricky too, because that's another thing I've looked at in the past. And then how do you keep track of it? Because then your manufacturing process has to be so tightly coupled with your code, right? Because now oh, well, I have this tray of chips and it's IDs, 6742 0 through 67429, and now I have these chips and I have to assign them somehow, and it's like, how do you actually utilize that unique number and keep track of it? It's almost like a serial number system you have to do, and it's because you have to guarantee that they're unique, or else if two of them have the same code or something, then you're screwed.
With the ATEX, you have to track the product. You have to have serial numbers, unique serial numbers, so you know if something's gone wrong, which product that is failed on. So you have to have traceability.
Gotcha.
And so one of the things that I did, because it's actually one of the reasons why I chose the chip in the first place. There were other reasons. I mean, I designed the network interface before I went with the LPC anyway. So it's I was using, at the time I was using like a DSP chip from Microchip, and then when we went with the second iteration, I ended up using that. But so what I ended up doing is every sensor that gets calibrated and goes through our system, we take that MAC ID and we pair that up to a serial number, like a more readable, a more user-friendly serial number, like with a prefix, PCB something.
Yeah, yep.
And then we will store that in a database. So I wrote for the products that I was doing for that company, I did every aspect. So I went from designing the electronics that you needed to actually doing the stuff that you needed for the production side of things. So I had the advantage that I could actually go and write the program that connects to the database. So I write the program that sample the data from the sensors, check that they worked. If they did, then we'll log that against their MAC ID. And then
right. So that's part of your calibration. That's part of your traceability all the way back to ATEX and stuff like that.
Exactly, yeah. And now the issue is though that yes, I got this unique MAC ID, but now what do I do? Then because the CAN IDs weren't, they don't easily pair up with the MAC ID. If that makes sense.
Right, because you might have 20 different sensors that all have their own unique ID, and then 10 of them go on one system, 10 of them go on another system.
Yeah.
The first 10 might have the ID 0 through 9, and the second ones might have the ID 0 through 9 as well, right?
Exactly.
On the CAN ID, stuff like that.
I mean, we tried all sorts. I mean, at one point we were pre-IDing them and then just literally writing the numbers on the actual probes themselves. Yeah. So when they went out, the customer can go ahead and see, okay, this is probe 5, so therefore that probe is for the 5th compartment. Because the thing is, the sensors, we had to associate the compartments so the drivers know which sensor is actually in which compartment. So the ID system we went for in the end were to match the compartment numbers and so on. So we saved like the first 10 CAN IDs for the first 10 compartments in our truck, for example.
Right, that works until truck manufacturers start naming their compartments A, B, C, D then.
Well, or Lucy or
exactly,
or Ben.
Right. This is the extra super plus compartment.
I'll come back to that in a second, but so to tell you what though, we tried doing that for a while. We tried putting ID numbers on the actual probes to send them out, only to find that the customers went ahead and just put the probes wherever they wanted. So like we've got documentation here which is completely traceable. It tells you exactly at this point that you should put probe 5 in compartment 5. What else do you want us to do? So in the end, we just kind of went, okay, we'll pre-ID them because we had to as part of the calibrations. Because at that point, I was able to actually calibrate 10 sensors at a time, kind of thing. So we'll send them out. But if you get this wrong, fine. There's a system you can follow that will try and rectify this. And you'd be surprised how often. Doesn't matter how many times we go out there and try our best to give the customers 5 probes with 5 unique IDs, they'll still go ahead and mix and match and get the driver calls up and say, I'm filling up compartment 5, but the display is showing compartment 1 filling.
Yeah, that doesn't surprise me at all. I mean, like that's what it comes down to, though. Like unless you have a completely integrated, like tightly regulated system where you are doing fully vertically integrated, where you're doing the actual end user integration as well, then you're always going to have people use it however they want to. And so the best you can do is just try and notify, like your system did. That's the best that you can really do.
Yeah, I tell you one thing. I knew I was in America, right? That my product finally made it to America. When I went there for, I think it was like a 2-week thing, and I sat on the side of the truck, because usually when we fit the display, we fit it on the left side of the truck, because just we drive on the correct side of the road, and so which is supposed to be safer. And so when you get to America, the driver's saying, "Well, we want the display on the right side," because that's what's better for us. And I was like going there and going, oh, because the way I laid out the display is that the compartments go from left to right. So compartment 1 is on left and compartment 5 is on the right.
Yeah.
Got to America, it's like, this doesn't make sense anymore.
Right, exactly.
So
and then do you change the firmware, or do you change just how they interface with it? Do you have different versions, that kind of thing? It's just
I changed the firmware. The thing is, working for a small company, you end up doing everything. So I'm there with my laptop on the side of a truck, not far from the highway. I think that's what you call it. So in one of the service stations, they're just coding away, going, "I want to turn this the other way around because I never thought we needed to turn this. Oh no, this has to go right to left." Yeah. And then made it back to the UK, and then I got told, "Can you make this a little easier for us to configure?" And going, "What else do you want?"
Right.
Well, what about drivers who may have to display on the back of the truck and going, well, you know what? I don't care.
They can code it themselves, damn it.
Yeah. If they think this is so easy, why don't they do it themselves?
Right.
I was like, and that's how you end up losing a job.
That is correct, yes.
No, but to be honest, though, I tell you that the most fun I've ever had in a field is always when you have to do panic work, when you ever have to kind of quickly code something or...
That's fun. That's fun for you. Usually, that I wouldn't think many listeners would agree with that.
I don't know. I
see you learn a lot for sure. Like no doubt about that. But like fun, yeah.
I tell this to people because the thing is though, I love what I do. I love electronics. I love working in bed. I love getting up in the morning and making something work. But I find it fun, or I guess you could say I sort of get my thrills when there's an issue that only you're supposed to fix, and you get it fixed. And
Gotcha.
I tell you, one of my favorite situations. So I got 2 stories, if you don't mind, because I think we're quite into this. So 2 stories I'll tell you. So it's one of my favorite ones, and my friend's gonna kill me for telling this. So the first one is, this is the first year into. I just started the job working at that company. My first week in, and my friend comes upstairs and kind of goes, "I'm having this issue with this board I designed a while ago." And what it is that it is an RFID tag system. And
what system? Sorry.
RFID tag.
Oh, okay. Cool. Yep.
Contactless, I think it's called.
Yeah. Yep. So like the however many megahertz, like the little coils that communicate with one another.
Yeah. So he's designed this system, and basically his board drives a relay, and the relay drives the signal, which tells the microcontroller, a second microcontroller, to let go of the handbrakes for the truck and make it safe. It's supposed to kind of prevent people from... Cause I should point out, so what happens is with trucks, when you're delivering, you actually have to leave the engine on to actually
because you need pumps and
power
stuff.
the pump.
Yeah,
exactly.
Right. Yeah.
And so quite often it's been the case where either the driver forget to put the handbrake on and the truck rolls down the hill.
Like idling or something? Like it just idles forward?
Yeah. And it's happened... You'd be surprised how often that has happened. You know what it's like. Something goes wrong often enough, someone's going to make an industry out of it.
Yep, exactly.
Or you could actually have somebody who just breaks into the truck, just opens the door and just starts driving.
Yeah.
Just drives off, and that could happen. Anyway, so he designed this board that basically automatically apply the handbrake once the truck is parked up, even though it's idling. And so it won't let go of the handbrake until you hit the tag with it. So also acts as a security system to prevent people from just driving off. But he was using a relay. I don't think it was his choice. I think it was the RFID tag, whoever designed that aspect. Was using a relay to drive the signal. And so what would happen is that if you knock it the right way, you can force the contact of the relay and causing a false signal. And so basically the issue was that he was reading from that signal directly. And I'm pretty certain a lot of your viewers would basically be shouting, "Debounce the signal! Debounce the signal!"
Right,
I'm certain they'll be saying that. Anyway, so it was like about a week or however long they were trying to figure out how to solve the problem. And at this point, they were thinking about redesigning the board. And, I only just started working there, and they came upstairs and said, "Ronald, you mind just coming down? I know this is going to be a bit much, but you mind just having a look?" And I came downstairs, and they described the issue, and I said, "Debounce it, mate." I kid you not, both long-time friend and long-time boss friend as well, both kind of looked and went, "Oh, yeah." Like,
oh, yeah.
Okay, this is what I'm here for.
Diodes, right, yes.
But it was just a software debouncer you had to do. All you had to do is just measure the signal, treat it like a switch,
yep.
And then you're fine.
Yep.
And so that was one of my favorite ones. So the panic one, sort of like moment of pressure. And this is when I realized that I like being under pressure because, I end up kind of... I like after the pressure's over, obviously. That's the bit that you realize I've succeeded and so on. So we were out in the field, same guy, and we were out in the field, and I left one of the crucial boards that I went out to fit. And all it was just an optocoupler in there, right? Mm-hmm. And basically converted 24 volts to something TTL. I think it was 5 volts at the time. Possibly, I think actually it's 3.3 volts. Anyway, it doesn't matter. And I left that board in Leeds, and we drove over 200 miles to the customer to fit it. And, I was panicking, what am I going to do? What are we going to do? What are we going to do? Well, guess what? There's a Maplins nearby. And so I kind of went, okay, I think I can whip something together in no time at all. So I bear in mind, I didn't have a soldering iron. I didn't have anything. I didn't even have components. I just had the company credit card, which is quite dangerous.
Mm-hmm. Okay.
And so went to the Maplins, and my friend was there going, okay, I can't find an optocoupler. I can't find anything. And we're like going, dude, this only needs to work for about a couple of weeks. And then the service guy's going to come back and actually refix everything. Anyway, he's going to remount new boards and all that. Anyway, so this is just a prototype. He goes, yeah, but I need to find the right optocoupler. And I just turned around and went, do we need an optocoupler? And said, all right, can we not just use a 5-volt regulator? That could take 24 volts.
Right, because it'll be low enough current and stuff like that, right?
Yeah, the only thing that we have to make sure is put a couple of extra passives in there just to make sure that it doesn't have any issues just being being turned on and off randomly. Uh-huh. Can we not just do that? And he goes, no, that's not going to work because, it's 24 volts. It needs to be properly safe and everything. I was going, look, we can buy a soldering iron from over there. We can get the variable from over there. We can get this 5-volt regulator here. 2 weeks' time, we'll be fine. We'll be back to it and we'll replace it. Okay, I did that. It worked. It was great. It didn't get replaced until about 2 years later.
See, okay, so I think I know what this is here. I think you have MacGyver syndrome. I think that's what you are. Yeah, that's what it is.
Yeah. Hey, it's a hero,
Yeah,
it's,
right.
But I tell you that it was just the fact that I was just standing there going, what can we do? Because I don't want to drive back another 200 miles to get this sorted out.
Yeah.
And that was one of that. To be honest, there was plenty of other failures that I'm going to conveniently not mention. So.
Right, of course. Well, that's good. No, so those were some great stories, man, and I appreciate you being on the show to talk about them a little bit. Obviously, at the end we should mention, that you are part of Contextual Electronics now, so that's cool, and I'm glad you're doing that. And you and I are talking about maybe doing a weekly video thing, so we'll have more details about that in the future. But weekly.
If anybody wants to listen to us.
Yeah. Well, we'd be doing video too. So.
Oh yeah.
Yeah. So thanks for being on, and thanks for telling us your stories. It was good stuff.
Thanks for having me.
Where can people find you online?
You can mostly find me on Twitter. So my username is OpticalWorm. Okay. I do have a company Twitter account, but to be honest, most of the fun is on my OpticalWorm, really. So that's the one to find me.
Cool. Okay, cool. Well, we'll have people follow you there, and we'll talk to you soon.
Yeah, bye.